Imagine you and your friend buy the same car with the same engine. Your car comes from a United States showroom. Your friend buys the exact model from Europe, Japan, or the Middle East. Same pistons, same bearings, same turbo, same everything. You open the owner manual and it says 0W-20 full synthetic. Your friend opens theirs and it proudly lists 5W-30 or even 5W-40. At first it feels like a tiny detail, just a couple of numbers on a bottle of oil. Then a mechanic in your town says one thing, an online forum says another, and suddenly this tiny detail feels like a $1,000 decision. Use the wrong viscosity and you invite extra wear, noisy cold starts, and early timing chain stretch. Use the right one and your engine runs smooth for years with that quiet confidence every driver loves. So why does this happen? How can one engine live on a paper-thin 0W-20 in the United States and the same engine live on thicker 5W-30 abroad? Is this climate? Is this marketing? Is this government pressure? Is this pure engineering? In this video, you and I walk through the full story together. We explore fuel economy laws, oil chemistry, engine tolerances, driving style, and what real mechanics and oil labs actually see inside these engines. By the end, you hold a simple checklist that tells you exactly when 0W-20 serves your engine and when 5W-30 treats it with more respect. Let us begin with real examples, because stories make this topic feel real. Take a Toyota sedan with the 2.5-liter 4-cylinder. In a United States manual, you see a big bold line that says 0W-20 full synthetic. In Australian, Japanese, or European service information for engines from the same family, you see a viscosity chart that includes 5W-30 and sometimes 10W-30 for warmer regions. The engine architecture stays the same. The compression ratio, the bore and stroke, and the basic lubrication system feel familiar across regions. You see something similar with a Honda 1.5-liter turbo engine. United States-friendly documentation focuses on 0W-20. Manuals and dealer stickers in many other countries suggest 5W-30, especially for hotter climates and higher speed highway driving. Now imagine a Subaru, a Mazda, or a small turbocharged Ford. Owners in one country fill with very light oil. Owners in another country fill with thicker oil, and both groups point to an official book and say, the manufacturer approves this. So the question grows bigger. If climate served as the only factor, Florida and Finland would display completely different recommendations on the label, and every warm region would share one oil grade. Real life tells a different story. Temperature plays a role, but the main driver lives somewhere else. To understand that deeper layer, you and I need to step away from the oil bottle and walk into a government office and an engine design studio. Every modern car sells inside a web of rules. In the United States, one of the most important sets of rules carries the name Corporate Average Fuel Economy, usually shortened to CAFE. This system sets a target fuel economy for each manufacturer's entire fleet. When an automaker submits a vehicle for certification, the government tests that car on a specific drive cycle and calculates official miles per gallon. A small change in engine friction can change that number, and a small change in that number can move an entire fleet closer to its target. Thinner oil slides through bearings more easily. Imagine swimming through water and then swimming through syrup. Your body feels the extra resistance immediately. An engine feels a similar difference at a microscopic level. When the oil film drops from the thickness of 5W-30 to the thinner film of 0W-20 at operating temperature, the crankshaft, camshafts, and piston skirts move with slightly less drag. On a test bench, that can yield a small but measurable improvement in fuel economy. For a single driver, that improvement feels tiny. For a company that sells hundreds of thousands of vehicles every year, that improvement can protect them from serious penalties, protect their public efficiency image, and help them advertise appealing fuel economy numbers. Engineers inside those companies understand this carefully. Management teams and legal departments understand the financial side just as carefully. Together, they choose an oil grade for certification that delivers an attractive fuel consumption figure, keeps emissions equipment happy, and still sits within safe limits for engine durability. This leads to a very important idea. The oil grade on the sticker of a United States car grows out of engineering, but also out of spreadsheets, emissions targets, and marketing promises. When you see that 0W-20 label, you see an engineering choice that leans strongly toward fuel economy. Before you and I go deeper into strategy and politics, we lay a simple foundation. The numbers on an oil bottle feel like a code, so we decode them in everyday language. Imagine you pour honey out of a jar in winter. It moves very slowly, almost like a solid. Now imagine you pour thin vegetable oil from a bottle. It flows quickly and coats every surface. Viscosity is simply the thickness of that flow. In an oil grade like 0W-20, the first number with the letter W tells you how the oil behaves at cold start conditions. W stands for winter. A 0W oil flows more easily through a cold engine than a 5W oil. The second number reveals the viscosity at normal operating temperature, around 100 degrees Celsius. A 20 grade behaves like a thinner film at that temperature. A 30 grade behaves like a thicker film. Data from real product sheets shows that a typical 0W-20 sits around 8.5 centistokes at 100 degrees Celsius, while a typical 5W-30 sits around 10 to 11 centistokes, which means a significantly stronger film at operating temperature. In simple terms, 0W-20 gives your engine a very easy cold start in winter and reduces drag once things warm up. 5W-30 flows slightly slower at a winter cold start, still very easily for most climates, and forms a thicker protective layer at full operating temperature and under load. Every time your engine revs at highway speed, tiny metal surfaces slide past each other supported by this protective oil film. A thicker film creates a wider safety margin when temperatures climb, when you drive at high speed for long periods, or when your engine works hard up a steep hill with passengers and luggage. Modern engines live in a different world from engines of the 1980s and 1990s. To meet emissions rules and fuel economy goals, manufacturers design engines with very tight internal clearances. The gap between a crankshaft journal and its bearing, the space between a piston ring and the cylinder wall, and the tolerances inside variable valve timing components all sit in a narrow range. Thin oil fills these narrow spaces quickly during a cold start and then flows through tiny oil galleries at high speed. Engineers design oil pumps, passage diameters, and relief valves with that specific viscosity in mind. A modern Japanese 4-cylinder with direct injection and variable valve timing can thrive on 0W-20 during its early life because the fresh clearances match that thin oil. At the same time, those same engineers know that engines experience wear over years of real driving. Bearings lose a little material, ring gaps grow slightly, and the entire lubrication system changes character. An older engine enjoys a little extra support from a thicker film. This explains why many experienced mechanics suggest a move from 0W-20 to 5W-30 or even 10W-30 as an engine passes high mileage, especially in warm climates or for drivers who frequently tow, climb hills, or sit in heavy traffic. You can imagine an engine as an athlete. A very young athlete moves easily in very light shoes. As the same athlete grows older and carries heavier loads, sturdier shoes provide better support, even when they weigh a little more. Your oil grade choice follows a similar logic. Now bring climate back into the conversation in a more precise way. Many drivers picture cold weather first when they hear 0W-20. They imagine remote snowy winters and sub-zero mornings. Cold start performance certainly matters. Oil that flows quickly on a winter morning reaches the camshafts and timing chain in time to prevent harsh startup noise. However, the other side of the thermometer tells an even more dramatic story. Picture summer traffic in Arizona, Texas, Florida, or the Gulf countries. Ambient temperatures sit well above 35 degrees Celsius. The radiator sees hot air, the air conditioning compressor runs constantly, and the engine oil absorbs heat from pistons, turbo bearings, and friction surfaces. In these conditions, oil temperature can climb into the range of 115 degrees Celsius or higher during heavy load. Laboratory and field tests from independent oil analysis services show that very light viscosity oils such as many 0W-20 formulas tend to lose a portion of their viscosity over longer intervals when they experience this kind of heat and shear. Slightly thicker formulas such as many 5W-30 oils display more stability under the same stress. Drivers in Europe, Australia, and the Middle East often spend long stretches at higher speeds on highways, sometimes far above typical United States highway speeds. Many of those regions combine that driving style with warmer ambient temperatures and long hills. Under those conditions, a thicker high-temperature viscosity grade fits the real world better, so regional recommendations lean toward 5W-30, 5W-40, or even 10W-40. In short, climate influences oil choice strongly, but the important climate factor lives in sump temperature under load rather than the frost on your windshield. With this background, you can stand in the engineer's shoes for a moment. The team designs an engine that passes durability testing on a range of viscosities. In the lab, that engine feels happy on both 0W-20 and 5W-30. Then the certification phase begins. For the United States market, the car goes through Environmental Protection Agency and CAFE fuel economy testing on a specific grade of oil. That grade, often 0W-20 for modern gasoline engines, becomes part of the official certification paperwork. Adjusting that grade later would require fresh testing and fresh paperwork. That path consumes time and money, and management usually prefers to invest that effort into an all-new model instead of a minor paperwork change. For Europe, Japan, Australia, or the Middle East, the same basic engine meets a different mix of regulations. Those markets care deeply about emissions as well, but their testing cycles, their fuel taxation, and their typical cruising speeds differ from those in the United States. In many of those markets, manufacturers also publish detailed viscosity charts that allow multiple grades based on temperature range. The handbook for a driver in Southern Europe or in the Gulf region frequently shows 5W-30 or 5W-40 as the main recommendation above a specific temperature. Regional warranty strategy also plays a role. In markets where long high-speed trips and hot climates dominate, brands choose thicker oil grades to preserve quiet engines and low warranty claims as vehicles age. Service campaigns and internal documents give dealers guidance that goes deeper than a single printed line in a global manual. This explains why you see a simple single line inside a United States owner manual, while you see a chart of options inside many manuals abroad. The engine stays the same. The rules around it change. Oil grades such as 0W-20 and 5W-30 describe viscosity, and they describe only one part of overall oil quality. Behind every bottle sits a set of industry standards that define wear performance, sludge control, turbo deposit resistance, and much more. In North America, gasoline engine oils follow categories from the American Petroleum Institute and the International Lubricant Specification Advisory Committee. Current categories such as API-SP and ILSA-CGF-6 include tests for chain wear, low-speed pre-ignition in turbo engines, and timing system cleanliness. These categories often encourage energy-conserving formulas and low-viscosity grades. In Europe, many manufacturers look first at ACEA sequences. These standards emphasize high temperature, high shear performance, and long drain intervals for extended highway use. Oils that carry ACAA 3 or C3 approval often come in 5W-30 or 5W-40 viscosity and deliver very strong film strength at high temperature. European performance engines, and many diesel engines, thrive on these thicker, more robust formulas. So a European manual that lists 5W-30 often refers implicitly to a robust ACA grade 5W-30, while a United States manual that lists 0W-20 usually points to an API-SP and ILSAC GF6 approved energy-conserving oil. Both categories aim to protect engines and emission systems, but they grow out of different driving cultures and regulatory histories. For you as a driver, this means quality matters as much as viscosity. A high-quality 0W-20 synthetic from a reputable brand delivers excellent protection in the right application. A high-quality 5W-30 synthetic with both API and ACEA approval delivers even stronger protection in high-temperature, high-load situations. Now step into the service bay and the oil analysis lab because theory feels satisfying, but real engines tell the most honest story. Independent mechanics in warm regions frequently share experiences of engines that feel slightly smoother and quieter after a switch from 0W-20 to 5W-30, especially on turbocharged engines that see spirited driving. Owners report a small drop in fuel economy on the dashboard display, often around half a mile per gallon, and a noticeable reduction in startup rattle and high-temperature engine noise. Oil analysis labs receive used oil samples from fleet operators, enthusiasts, and everyday drivers. Their reports often show that used 5W-30 samples from hard-driven engines retain more viscosity reserve and slightly lower wear metal counts than used 0W-20 samples from similar service. These trends appear especially clearly in hot climates and during long highway intervals. Online communities of enthusiasts, professional mechanics, and engineers mirror this pattern. Conversations around Honda small turbo engines, Toyota 4-cylinders, and various Subaru models frequently include successful experiences with 5W-30 in regions where manufacturers promote 0W-20 mainly for fuel economy labeling. These stories create a simple message. Both grades can serve an engine well. The grade that matches climate, driving style, and engine age most closely gives the most satisfying results, both in feel and in long-term cleanliness. So far, you and I focused on viscosity, which describes thickness. Oil performance, however, comes from more than simple thickness. Inside every bottle lives a carefully balanced chemistry set of detergents, dispersants, anti-wear agents, friction modifiers, and base oils. Detergents and dispersants hold soot and varnish precursors in suspension, so they leave the engine with the old oil instead of plating onto metal surfaces. Anti-wear additives such as zinc and phosphorus compounds form sacrificial films on high-pressure surfaces, especially in camshaft lobes and timing components. Friction modifiers help the oil glide across surfaces more easily, which supports fuel economy. The base oil layer, whether highly refined mineral oil, hydrocracked Group 3, or synthetic Group 4 and Group 5 material, controls volatility and high temperature stability. One 5W-30 oil may include a very robust additive package and synthetic base oils, which allows it to handle temperatures and shear loads that would challenge a cheaper 5W-30. A premium 0W-20 with ester-rich synthetic base stocks and strong anti-wear chemistry can protect better than a budget 5W-30 conventional oil. Manufacturers understand this clearly, which explains why some brands extend oil change intervals on engines filled with high-quality 0W-20 synthetic formulas. Toyota, for example, pairs approval of specific 0W-20 synthetics with 10,000-mile service intervals for many engines because the chemistry inside those oils maintains viscosity and cleanliness over that distance. So when you choose between 0W-20 and 5W-30, you also choose between different quality levels. A wise strategy combines the right viscosity with a reputable brand and a specification that either meets or exceeds your manufacturer's requirements. An engine fresh from the factory feels tight, clean and beautifully sealed. Crosshatch marks on the cylinder walls hold oil perfectly. Bearings sit exactly where engineers designed them. Seals feel supple and strong. In those early years, thin oil provides all the protection the engine needs, as long as service intervals stay sensible. With time and mileage, every component experiences gradual wear. The crosshatch pattern softens, ring gaps grow a little, bearings polish and lose microscopic material, and seals face years of heat cycles. Oil control rings start to work harder to hold back combustion gases and to scrape excess oil from the cylinder walls. At this stage, a slightly thicker oil often delivers a quieter engine, cleaner oil analysis reports, and lower consumption. Many seasoned mechanics observe that engines with more than 96,000 kilometers or 60,000 miles respond very well to a shift from 0W-20 to 5W-30, especially in climates with hot summer. Think again about the athlete metaphor. A light shoe fits perfectly during youthful training. As the body accumulates mileage and strength work, supportive shoes with slightly thicker soles protect joints and extend the athlete's career. Oil follows the same principle inside your engine, so the grade inside your owner manual provides an excellent starting point for a new engine. The grade inside your sump 10 years later can evolve gently based on real-world observations of noise, consumption, and driving environment. Whenever drivers hear ideas that differ from the exact line in the manual, a very understandable fear appears. They worry about warranty, dealership arguments, and denied claims. Consumer protection law in the United States creates a clear framework for this situation. Manufacturers carry the burden of proof when they claim that a particular product or modification caused damage. High-quality oil that meets or exceeds the specification in the manual qualifies as an approved lubricant. A viscosity grade shift within the range that the engine family uses in other markets sits squarely within reasonable use. Service bulletins in many brands explicitly allow alternate viscosities under certain conditions. These documents often state that 5W-30 serves as an acceptable fill when 0W-20 is unavailable, as long as it meets the same performance category. This language reveals a simple truth. Engineering teams validate these engines on multiple grades. Market strategy chooses one grade as the headline in each region. For maximum peace of mind, drivers can keep service receipts, choose oils from reputable brands that carry the right specifications, and discuss any change in viscosity calmly with service advisors. Clear, confident communication usually leads to smooth service experiences, especially when you can point to examples of the same engine using 5W-30 or 5W-40 in other countries. At this point, you hold plenty of theory. Now we turn that into a practical checklist that fits easily in your mind every time you stand in front of a shelf of oil bottles. First, consider climate. In very cold regions with long winters and frequent sub-zero starts, 0W-20 or 0W-30 serve cold start wear very well. In warm or hot regions, or in areas with long summers and heavy traffic, 5W-30 or even 5W-40 provide stronger protection at real operating temperatures. Second, consider driving style. Short trips, gentle city driving, and relaxed suburban commutes create fewer extreme temperatures inside the engine. Long highway trips, towing, spirited driving, mountain roads, and frequent high-load situations push oil to its limit. The more often your engine works hard, the more you benefit from the thicker, high-temperature film of 5W-30. Third, consider engine age and mileage. A fresh engine during its early years thrives on the thin oil listed in the manual, especially when service intervals stay conservative. As mileage climbs and wear accumulate, a gradual move toward 5W-30 supports compression, reduces noise, and often trims oil consumption. Fourth, consider oil quality. Choose well-known brands, look for API, ILSAC, and ACEA approvals where relevant, and match the specification code in your manual. Synthetic formulas handle heat, deposits, and long intervals far better than basic conventional oils. Fifth, consider regional recommendations. Seek out service manuals or owner manuals for the same engine in Europe, Australia, Japan, or the Middle East. When you see 5W-30 or 5W-40 in those documents for similar or hotter climates, you gain strong evidence that your engine family feels perfectly comfortable on those grades. Finally, listen to your own engine. Pay attention to startup sound, idling smoothness, and oil consumption between changes. Your ears and dipstick deliver valuable feedback. You now see why two drivers with the same engine, living on different continents, pour different oil grades into the same metal. United States regulations pull manufacturers toward very light viscosities that support attractive fuel economy. Labels and certification targets. Other regions balance those pressures with hotter climates, higher cruising speeds, and longer highway trips, which leads to thicker recommendations. Engine design teams build tolerance for several grades into their creations. Oil companies fill shelves with high-quality synthetics across the range from 0W-20 through 5W-40 and beyond. Mechanics and oil labs quietly observe how these combinations behave in real engines and share patterns that line up beautifully with engineering theory. The heart of the story feels surprisingly simple. 0W-20 shines in cold starts, short trips, and situations where maximum fuel economy matters. 5W-30 shines in heat, load, and age, especially when you value long-term durability over a tiny gain at the fuel pump. So the next time you stand in the parts aisle with 2 bottles in your hand, remember this conversation. Picture the climate where your car lives, the way you drive, the age of your engine, and the oil quality in front of you. Then choose with confidence. Every driver deserves a clear, honest explanation of this topic. Marketing teams love simple messages. Manuals aim for one line that fits every situation. Real engines live richer lives than a single sentence can describe. Your car carries you, your family, your work, and your dreams through daily life. A thoughtful oil choice acts like affordable insurance for that mission. Thin oil and thick oil both have a place in your toolbox. When you match the grade to your climate, your driving style, and your engine's stage of life, you give that engine the treatment a hard-working machine truly deserves. If this breakdown brings clarity, share it with a friend who stares at oil bottles in confusion. Subscribe for more deep dives into the hidden engineering decisions that shape your car. Together, we turn complicated charts and regulations into simple choices that keep your engine strong, quiet, and ready for every journey ahead.